Now today we're going to do some more probability, except now we're going to include something that's called a sample space. Let's go ahead and practice what we learned yesterday first. I'd like you to pause the video and answer these questions. A number cube is rolled one time. Find the probabilities and write them as a fraction, decimal, and percent. Go ahead and pause and then play the video to check your answers. All right, let's go ahead and check your answers. The first one is the probability of rolling a 5. The probability of rolling a 5 would be 1 out of 6. Now we also need to write this as a decimal, so we take 1 and divide by 6. That equals 0.16 with a repeating bar over the 6. And as a percent, this would be 16.7%. Next, the probability of rolling a number greater than 4. That would mean rolling either a 5 or a 6. So that's 2 out of 6, which is 1/3. As a decimal, that is 0.3 repeating. And then as a percent, that would be 33.3%. Okay, the probability of rolling an 8. Well, there aren't any 8s on a dice, so that would make 0, which would equal, as a decimal, the same thing, 0.0, and as a percent, just 0%. And lastly, the probability of rolling an even number. The even numbers are 2, 4, and 6, so that's 3 out of 6, which is 1/2. As a decimal, that equals 0.5, which is 50%. Okay, now let's do something new. Let's say that 2 number cubes are rolled one time. If you rolled 2 number cubes, what are some possible outcomes? You could roll maybe a 4 and a 6, or you could roll a 1 and a 2, or maybe 3 and 3, or 6 and 4. What are all of the possible outcomes? This is called the sample space. In order to organize all of our possible outcomes, we're actually going to make a chart. So up on the top here, let's go ahead and list out all of the possibilities of rolling just one number cube. You could get a 1, a 2, a 3, 4, 5, or 6. Now on the second number cube, let's go ahead and list those going downwards. 1, 2, 3, 4, 5, and 6. Now if I roll both of these number cubes at the same time, one possible outcome would be to get a 1 and a 1. Another possible outcome could be to get a 1 and then a 2. Another possible outcome would be 1 and 3, 1 and 4, 1 and 5, and 1 and 6. Hopefully you see where I'm going with this. Go ahead and fill in your chart. The next row would be rolling a 2 followed by a 1, then a 2, 2, 2, 3. Go ahead and fill out your chart. And just like magic, our chart is filled in. This is our sample space. So now what we can do is we can find different probabilities by looking at this chart. For example, if I wanted to find the probability of rolling, let's say, a 4 and a 2 in that order, then I would just look at my chart and say, well, 4, 2 shows up one time out of how many different boxes and different options do we have? 36. Or maybe I say, what's the probability of rolling a 1 or a 3 in any order? Then we'd look on our chart and find where the 1 and the 3 are. So there's 1 here, and there's 1 here, and that's it. So that's 2 options out of 36. Or maybe I'd say, what's the probability of rolling a 3 and a 5? Then I find everywhere where there's a 3 and a 5, there's one here and one here. And so that, again, would be 2 out of 36. And we should reduce those, of course, to 1 over 18. Okay, so now let's go ahead. You have your chart on your paper. Use your chart to find the following probabilities. The first one says the probability of rolling a 2 and a 3. So look at your chart and find everywhere that you see a 2 and a 3. And when you look at your sample space, there should only be 2 options out of 36, which would be 1 over 18. The next one says the probability of rolling a sum of 7. So now what that means is when you add the 2 dice together, it equals 7. So all the possible ways of getting a 7. Go ahead and look at your sample space and find all the ones that add up to 7. If you counted correctly, you should have counted 6 different ways to add up to 7 out of 36, which is 1/6. The next one says, what's the probability of rolling a sum of 3? So adding them up, how many different ways can you get a 3? If you added correctly, you should have found that it showed up 2 times out of 36, which is 1/18. Next, the probability of rolling a 5 or a 6. So either 5 or 6 in that order, or a 6 and a 5. Count how many times you see a 5 and a 6. Okay, that shows up 2 times out of 36, which is 1/18. And lastly, find the probability of rolling a sum that is even. So after you take the sum, it has to equal an even number. Count how many even numbers you end up getting after you add them up. And we get a grand total of 18 out of 36, which equals 1/2. Nice job using sample spaces. Now don't lose that paper.